Hi and welcome to my channel How Stuff Works. In this series we will be looking into CNC, particularly DIY CNC. CNC is a passion of mine. I work on CNC equipment and I build them for hobby and business purposes. So let's get into it. We will break down the series into short, easy to follow sections. This will allow beginners, as well as seasoned DIYers, to help with building your own or just helping troubleshoot an existing rig. Part 1. Questions for yourself. So let's talk about probably the most important decision you will make is: what do I want my rig to do? Do I want it to draw? Do I want to mill, carve, root or wood? Do I want to mill or carve metal? CNC machines, as you may have realized, are highly versatile and capable machines. So now you have decided what you wanted to achieve, let's move on to other considerations. I guess the next subject to consider is what size, working or cutting area you want to work in. Hobbyist machine will range from desktop size units right up to an area that can cut a full sheet of 24 by 12 stock. CNC machines on an industrial setting cut sheets of particle board chipboard up to 3 meters by 1.8 meters. Most of these machines are built to make kitchen cabinets or large furniture, carved bed heads for example. Your machine, I will imagine, be much smaller but no less impressive. Once you have decided this factor, we can get into the next set of design principles. Okay, so let me ask you a question. What is the weakest part of any mechanical build? Answer: is the least poorly designed and considered part. When I started considering my rig, I just wanted to get in there and get cutting. I wanted to cut and carve both wood and metal on the one rig. I jumped the gun and searched the internet for design ideas, and yep, I found DIY kits. The websites looked impressive, they made the machine sound fantastic and could make anything. Sadly not so. My first machine was a knocked CNC. Now please understand, the aim of this section is not to say these machine designs are poorly constructed. On the contrary, the DIY kits I found would operate wonderfully as small format, probably not much bigger than a desktop unit, up to maybe under 1 square meter in total area. The reason for this will be discussed later, is their structural build. Now before you go whoopee and start buying parts and get out of your depth, which is what I did, really consider again what you want to make. Do you want to just make keychain jewelry, or do you want to make furniture? As the saying goes, don't try run before you can walk. If you want to make small items, maybe a pre-built machine from an online service is your choice, but if you want to make large format items, and a commercial machine is out of your price range, then what we will discuss next is more your choice. Part 2. Construction choices. So you have decided what you want your rig to do. Now deciding what to make it from. Depending on what you chose in our previous section, what you want your rig to do will determine your next step. So what is your budget? I will tell you now before you get started that this hobby can become very expensive, and both money and time. But the end result is very rewarding and very worth it. Now unless you buy a desktop machine, your budget honestly will more than likely exceed several $1,000s. If you want to do it right, and do it right the first time. I discovered that buying a DIY kit and discovering its limitations, that I was left to continually upgrade or rework existing setup ideas to make it work the way I needed it to. Okay, so I posed a question to you earlier. What is the weakest part of any mechanical build? And you know the answer, because I gave it to you. If there is any part to a CNC machine that you need to be sure of, is everything. So given that, let's start with the ground. Many industrial CNC machines are incredibly heavy, ranging from hundreds of kilograms to several tons. It is this that gives them their strength, or a common word you will hear is rigidity. Your build won't have this to back it up, and if it did, you would need a crane to move it. If you move your machine, is going to be more of a break it down into smaller parts for transport if you move home. So you are going to have to make up for the weight option with other methods to increase rigidity. So if you have a workshop with a concrete floor, then that's perfect, you are already going well. If you don't, I would suggest you consider getting a shed with enough workroom for your new pride and joy, or at least an undercover area that has a concrete floor. The reason I am starting on the floor is based on the question previously asked. If you don't have a solid base, then the physical forces you will create using this machine will jog it about and cause it to shift, This can create errors in your projects during cutting and even damage your machine. In many other videos I have many DIY builders have their machine mounted on wheels. I feel this is a bad design choice as detailed above, as the laws of motion will cause the machine to move and react poorly. So you have a flaw. The next thing is, what are you going to mount your machine on? A reinforced frame made from very strong hardwood members or even better RHS steel. These frames are incredibly sturdy, allow very little movement when designed right. If you have no intention of moving and are sure you don't want to move your rig, then welding your frame, when made of steel, is the best option. If your future is uncertain, then bolting with correct cross-bracing is a must. If making your frame of wood, then correct cross-bracing technique is essential. I hope you have enjoyed this entry in CNC design and a foray into DIY CNC. In our next episode we will look into different materials commonly used in CNC frame design.